Hello, 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 everybody, and welcome to Science. Thank you for that quick turnaround and coming back to science class here on YouTube. Today, we're continuing our look at solutions and asking this question of, are all solutions created equal? Particularly, are all solutions with the same materials, the same solvent and solute, created equal? Here's what you're going to need. You're going to need your science notebook and a pencil or pen to take notes on today's investigation. And down here are all of our I cans. There are many of them, and most of them are vocabulary related. So I can define solution, which is a word that we first defined last week. We're going to get some new vocabulary today: solvent, solute, we'll find out those in a minute, and also dilute or dilute, and concentrated, diluted and concentrated. Okay? And then also I can compare two solutions of different concentrations. So let's get right into it with a little bit of vocabulary. And here's our word wall over here that we can use. So just as a reminder, there is solution. It says a substance mixed with a liquid. Now, it doesn't always have to be a liquid, but for purposes of right now, we're going to say it's a liquid. In particular, we're using water. A substance mixed with a liquid where the substance seems to disappear, so we have some transparency, meaning you can see through our solution, and it cannot be separated by a filter. That's what differentiates a mixture from a solution. A solution is a type of mixture, but not all mixtures are solutions. It's kind of a rectangle and square sort of a thing. Okay? There are two parts to a solution, two main parts, and they are listed right there and there. Our solute is the substance that is being dissolved. So in the case of our saltwater solution from last week, what was being dissolved, or our solute, was the salt. Okay, that's the thing that's being dissolved, is disappearing into our solvent, which is the stuff or the material that the solute is dissolving into, okay, to create that solution that cannot be separated by a filter. It can be separated, as we saw from last week's experiment where we evaporated away the water and we were left with the salt in our little observation trays. Okay, and so it can be separated out, but not with a filter or not with any like mechanical means. It's just going to have to be separated by evaporation or some other way of getting rid of the solvent. Today, the solute we're actually going to be talking about soda today. I have our like soda mix from the SodaStream thingy. We're using orange soda because I love orange soda. Full disclosure, this is actually already kind of a solution on its own. It's a sugar and water solution. But for the purposes of this experiment, we're going to be talking about this as the solute of our soda mix as our solute here. It's going to be dissolved into our solvent, which is, in this case, water. Okay? Pretty unfortunate time to be in distance learning because this is a experiment. This is an investigation where we are allowed to taste the science, but unfortunately you will not be able to. If you had like a SodaStream at home, or you had some like Kool-Aid or Crystal Light or some other like drink juice powder, okay, you could replicate this experiment at home, and I encourage you to do so if you are able and you have the supplies. Okay, and what we're going to be testing today is we're going to be looking at different proportions of solute and solvent. Essentially, what we're going to be looking at is, are our solutions the same if we add like more syrup than water or more water than syrup, and looking at the different ratios of solute to solvent and seeing if that affects the way our solution comes out. Okay, so behind me, and let me move the word wall out of the way so we can copy down this table. And let me pull the camera up there. Ta-da! So starting with, I'm going to go this way with it, everything's like backwards for me, so if I move in the wrong direction, that's why. So you're going to need 4 rows, A, B, C, and D. Okay, and then you're going to need 1, 2, 3, 4, 5, 6 columns in our table. Okay, the first column there, right there, okay, that says solvent volume. So how much water are we going to have in each solution? Okay, and you can see there, A, B, and C will all have the same amount of solvent, the same amount of water, which is 150 milliliters. It's 3 of these. Each one of these is 50 milliliters, so I put 3 of them in our container here, in each container. And then the second column is going to be our solute volume, the amount of syrup that we are putting into our solution. Okay. For A, it's going to be 5 milliliters, and I pre-poured a couple of them, so you can see some syrup already sticking in there. But 5 milliliters, that's how big this spoon is. Okay. For B, it's going to be 15 milliliters, which is this spoon here. You can see the difference if I hold them side by side. Okay, so which one is larger? The 5 or the 15? Yes, the 15 is larger. In fact, it is 3 times larger because 3 times 5 is 15. Okay, sample C is essentially the same thing as sample A, 5 milliliters. And then sample D, you'll notice the difference. It's also 5 milliliters of solute, 5 milliliters of syrup, but we've got way more solvent, 450 milliliters of solvent. Okay, so take a minute to copy down that chart. The other things you're going to need, don't worry about that last bit yet, but what you're going to need in the immediate future are going to be the next 2 columns of color and taste. The taste is going to be me describing the taste. If you replicate this at home with something else that's drinkable, you could taste it and compare for yourself. Okay, so I'm going to come back here, make sure you can still see the table. Yes, you can. Okay, and now what I'm going to do is I am going to prep sample A. So I've already got 150 milliliters of solvent, of water, and then I'm going to add 5 milliliters of our syrup. So measuring out 5 milliliters. Okay, try not to spill because it's sticky. And then I'm going to tilt you down so you can see the mix. Ready? Okay, give it a little stir here. Really dissolve all of that solute, all that syrup into the water. Okay. If we were just using sugar and water, we could also do this as an experiment. But I thought orange soda, 1, I like to drink it, and 2, it's quite colorful, so we get more of a color fix there. Okay, so there is sample A. Okay, I'm just going to put it to the side over there. Now, let's go with sample B. Okay, now, same amount of water. Again, if we go back up, same amount of water, 150 milliliters. Okay, only the difference is going to be the amount of solute we put in, the amount of syrup. In this case, we're using our big spoon, our 15 milliliter spoon. Pouring, pouring, pouring. Okay, tilting it down, ready, and go. Boom. Gonna give it a stir, gonna give it a nice dissolve there. Okay, so try and get all the syrup out of there. Some stuck in the spoon, as you can see, because this is quite sticky, because again, it's sugar water. All right, so now let's do a little bit of a comparison. So take a look at samples A and B. What do you notice first about the color? And make sure to take those notes on the color section in your table, in your science notebook. Okay, so A and B. Tilt it back down so you can see again. There's A, there's B. I'll even give them a little, there we go. Right, definitely kind of like a darker, brighter orange here, right? This one a little bit thinner. Okay, if we were to hold them up a little bit, you can definitely see, right? Going this way. Differences between A and B, right? A is a lot darker, a lot less transparent, so I almost wonder if maybe there's so much syrup in there that it's not fully dissolving. Okay, they're both orange, but I can see through A a lot easier than I can see through B. Okay? Should we give a taste test? Here we go. So here's the taste on, I need a cup. Hold on. Come with me on a journey to get a cup. Ta-da! Because the microphone is plugged in, and I don't want to send my computer flying across the room. Here we go. All right. Taste test. Sample A. Here we go. Tastes like orange soda. Some sweetness. Not very sour. It tastes like, you know, well, it's not carbonated, but it tastes basically like a flat orange soda. Okay? Let's see, Fiona said we added in the same amount. In these cases, we didn't. B has 3 times the amount of solute as A. Okay, so 15 versus 5. So here's B. I can already make a hypothesis. I think this one's going to be sweeter, because obviously it's got 3 times the amount of syrup in it. Even on smell, I know this is going to be sweeter. Ha! Okay. Oh, that was like a liquid pixie stick. Wow. It's like it went past sweet to that like kind of tart, tangy sort of thing. Wow. Much, much sweeter in color, or in taste, and much, much different in color. So there's A and there's B. All right. You can even see it from afar, right? B is a lot kind of darker and more of a reddish than A. Okay. So that was A and B. Now we have C and D, and I prepped these early. All right. So here's C. Again, this is the same proportions as A. Okay. 150 milliliters of water, of solvent, 5 milliliters of solute, of our syrup. Okay. Now, think about, before I show you D, think about make a prediction, what you think it's going to look like. Thinking about D has the same amount of solute as C, but it's got 3 times as much water, 3 times as much solvent. So what do you think D is going to look like in terms of color, in terms of transparency? Here we go. Here's D. Bum, ba, da, bum. There it is. So there's C and D. Not as big of a change, right? Looks a little similar. You can definitely, there's more of a transparency to D. I wonder if I can capture that on video. It's a little darker. It's harder to see here. It's easier to see if you were here, particularly with the transparency piece. There we go. Like you can, oh, maybe not. I was going to say, I think you can see my finger through. I can see my finger on the other side of the thing, but it's not coming out on video, unfortunately. But you can tell there is a difference in color. C is a little bit darker. Not as evident as A and B, huh? But still similar, okay? Let me show B and D to really compare. So here's B again, and then here's D, right? Very, very different. And C kind of, A/C, because they're the same concentration, kind of sit in the middle. Okay, so now we've done the color. Let's taste test C and D. Well, C, again, it's just like A, so cleanse my palate here. Yep, again, same as A, right? Exact same proportions, so it tastes exactly the same. Now let's go with D. The most water, let's see. Let's make a prediction here, right? B was a lot sweeter, heck of a lot sweeter and more flavorful and punchy than A and C. So what's D going to be if it's got more water, more solvent, but less solute? Yeah, that's boring. Tastes, it's very, very weak. You don't get a lot of the orange. Mostly just tastes like, you know, if you like have like a glass of soda or a glass of juice, and then afterwards you like put water in that same cup, and it tastes like water, but there's still a hint of like what you drank before it. This is that. Okay, very weak. Definitely some orange flavor in there, but if you tried to sell this as a soda, I don't think it would be very popular because it's not very flavorful. Okay, so that was color and taste. Now what we're going to do, another aspect of solutions and comparing them is, whoop, there it is right there. This column here, column 5, says, if I go all the way up close to the title, it says mass of 50 milliliters. Okay, so what I'm going to do is I'm going to take a 50 milliliter sample, or spoiler alert, I already took them. I'm going to take a sample of 50 milliliters of each solution, and then we're going to weigh them. My hypothesis is that the more solute, the more syrup is in there, the heavier it will be, because sugar is heavier than water. So that's going to be my hypothesis, and all that stuff in there, along with like, there's like citric acid in there to make it a little tangy, and there's flavors and a bunch of stuff that I'm sure isn't good for me because it's soda. But I'm sure, my hypothesis is that all of that stuff is heavier than water, so the more solute to solvent ratio, the heavier it's going to be. So we're going to find out. All right, here we go. Let me get my scale. All right, so here is my scale. If I tilt it down slightly, okay. It is currently evened out, and then I've put a cup, an empty cup, on the other side to control it. So here is A. All right, now I've got to add weight until our scale is evened out, our balance is evened out, and at that point we will know the mass of this amount. So I'm going to start with a 20 gram. Okay, start with another 20 gram. Nope, need more. Should we go with 10? Aha. Okay, so what we're looking at is an even 50 grams. Curious. Okay, so for A, it is 50 grams. And spoiler alert, it's also C, because they're the same proportions. So it's the same sample. All right, now, let's try it with B. Back to my empty cup. Grab B here. Remember, my hypothesis is, since this one had more solute in it and the same amount of solvent, it's actually going to be a little bit heavier than 50 grams. Let's find out. So here's our 50. Okay. Let's go one at a time. That moved it a little bit, but not quite. Let's do another gram. Still not all the way there. I'm looking at the little needle on the other side of it here, and I can see it's still a little bit tilted. There we go. Now we're even. Doesn't look even on the doesn't look even on the screen, but it is even here. Trust me. It's because our table's a little slanty. But that was 50, 20, 40, 50, 53 grams. There they are, 53 grams. So if we look up at our chart, the mass of 50 milliliters, if I have a marker somewhere. The mass of 50 milliliters with A and C, we had 50 grams. And with B, we had 53 grams. Now let's think about D. Has the most solvent as it relates to our solute. So, do we think it's going to be more or less weight, more or less mass than A and C? Let's find out. We'll start with 20, 40. Now, if my hypothesis is correct, this will tip it too far. So I'm going to start with a 5 instead. Already started to move. Let's see. Another one. Ooh, okay. That's 40 for it to 46 now. Another 1 grammer. 47. Oh, we're tilting. 48. Almost there. 49. And yes, we are at even. 49 grams. 1 gram shy. So we go back up to our chart here. We can see that, yeah, on a smaller level, right? It's only the difference of a couple of grams, but it still makes a difference. Okay, we have our most solvent to solute ratio, our highest solute to solvent ratio, weighs a little bit more. Okay, so more proof there that our solutions are created a little bit differently. Okay, the last thing over here is what I'm calling our concentration diagram. Okay, concentration, when we talk about something being concentrated, we talk about how much solute is in a solution compared to its solvent. Okay, so the more solute, the more dissolved stuff is in our solution, the more concentrated it is. The less stuff is in there, the less solute, the less concentrated or the more diluted it is. Okay, so we can see here on the word wall, dilute or a dilution, diluted, a solution with a smaller amount of solute or a larger amount of solvent. So less syrup, more water equals more diluted. Okay, the opposite of that would be concentrated, a solution with a large amount of solute or a smaller amount of solvent. Okay, so this, in essence, because it's already sugar and water, this is a really concentrated solution of sugar and water. Okay, and by adding more water to it, we're diluting to make it drinkable. Okay, if you've ever bought the like frozen cans of like orange juice where you mix it with a couple of cans full of water to make orange juice, right? That's why it's called orange juice concentrate. Okay, it needs to be diluted with water to make it drinkable. So you're making a solution in that case, right? When you're making juice, or you're making iced tea, or you're making coffee, all of those are solutions. okay, in water, especially with coffee, right? Coffee is an interesting one because, yeah, you have to use a coffee filter, but there are what are called soluble materials in our coffee beans. Okay, it means they can be drawn out and dissolve into water. Okay, some parts of the coffee bean, the bigger particles, aren't soluble, so they get filtered out. Otherwise, you're just drinking a bunch of gritty coffee, and it's not very exciting. Okay, but coffee beans are soluble to a point, which helps us make coffee, which is a solution of coffee beans and water. All right, so the way let me move our word wall out of the way again. There we go. The way we think about a concentration diagram is the more concentrated our solution is, we want to be able to show that. So if we have A and B here, I like to just use X's. So I might say, particularly with 5 milliliters, I might go to show the 5 milliliters of syrup, right? With our B, okay, we got 15 milliliters. Okay, so showing there, right, the more X's you've got, the more concentrated our solution is. Okay, C was the same as A, so we might draw something similar, same amount of X's. And then D was our least concentrated, our most diluted, so we might just put a couple. Okay, so then we can see visually, look at that, right? B is the most concentrated, it's got the most kind of X's representing our solute that's been dissolved in there. A and C in the middle, D our least concentrated, our most dilute. Make sense? All right. On your exit ticket today, you are going to be asking some questions, making some comparisons. So being able to say this one is more, this one is darker or less transparent, or lighter or more transparent, right? And then asking you to explain and answer our question, are all solutions made with the same materials truly the same? Okay, and let me pull this back up, do use these vocabulary words in your answers. So don't just say there's more of it, say it's more concentrated, right? Don't just say there's more water, try using solvent instead of water, okay? Try using solute instead of syrup. Okay, practice that scientific vocabulary because it's going to pay off down the road. It's going to give you more comfort with that vocabulary. All right, good luck on the exit ticket. I'm going to drink a bunch of this soda and then go do some cartwheels or something because I'm going to be all jacked up on sugar. So enjoy. Again, I encourage you, try this investigation at home. If you've got, if you've got a soda stream and you've got syrups, you can try it, okay? If you've got Kool-Aid powder or Crystal Light or any other soda powder you can get at the grocery store, try it, right? If you've got tea, you can experiment with the concentration of tea, right? 1 cupful of hot water with 2 tea bags versus 1 cupful of water with 1 tea bag versus 1 pitcher full of water with 1 tea bag, right? What are the differences in concentration and dilution? All right, good luck, happy science, and we will see you soon.